Remember when SUVs used to come with a warning sticker on the visor, essentially saying if you corner too hard, the car will topple over? Rolling SUVs is actually pretty common, and manufacturers often have to put special consideration into their design in order to pass the various safety tests before being sold. Not Tesla though. They created a car that is so roll resistant that they couldn't get it to stay upside down, even when they tried, making it the first SUV to ever achieve a perfect score on this test. So, how did they do it? It's clear that Tesla cares a lot about the safety of its cars. When crash tested by the US Traffic Safety Administration, the Tesla Model X was the first SUV to ever score 5 stars in every single category, not just the rollover tests. And there are a number of reasons for its impressive performance. A lot of that is down to its electric drivetrain rather than having the combustion engine and drivetrain that's typically used. Firstly, there's no bulky engine in the front of the car, so the crumple zones could be much larger. Typically, the engines have to be mounted high in an SUV to allow for good ground clearance below the sump, as well as having sufficient room for the four-wheel drive system. This normally works with 3 differentials, one in the middle that is driven by the engine, and then one on each axle. But this means that the drive shaft that powers the front wheels has to go under the engine, which means that the engine has to be mounted even higher. So essentially, all of the heavy mechanical bits have to be mounted way up high, making the center of gravity high up. And this is the very reason that SUVs are so susceptible to rolling. The center of gravity is defined as the point where the total mass of the car can be considered to act, almost like an average of the location and quantity of mass throughout the car, essentially meaning this is the point at which you could balance the car. The lower the center of gravity, the less weight transfer a car will undergo while accelerating, braking and cornering. A bit like a lever, the lower the center of gravity, the shorter the lever. The difference between a double-decker bus and a sports car. This is one of the very reasons why race cars are so low to the ground, and why Ferrari have even removed the seat runners from the LaFerrari. This means they can have the passenger's weight lower in the car, and according to Ferrari, dropping the center of gravity by just 10 millimeters saves 4/10 per lap at Monza. Tesla's electric drivetrain allows them to sidestep these issues. They're able to place the bulk of the mass low in the car, so the batteries weigh over 600 kilograms out of the total 2.5 ton curb weight, and they have mounted them in the ideal location, central and very low, built into the floor of the car. They also don't need to worry about the drivetrain problem, as the Model X P100D has a motor on each wheel, meaning there are no long drive shafts to deal with. However, this system does come with a couple of drawbacks. Batteries can be dangerous in a crash, and so Tesla have to really protect them from this. In simple terms, these electric car batteries are made up of thousands of smaller batteries, and if these get dented or punctured, they short circuit and dump all of their energy in one go, creating incredible heat and potentially starting a fire. Now, there are several electrical systems in place to stop this from happening, but they also have to shield the batteries to stop the impact from happening in the first place. And they do this with the use of an incredibly strong aluminium chassis design, as well as lots of mechanical shielding around the battery. It does its job very well, but comes with the downside of even more weight. So Tesla have used a lot of clever design to place the center of gravity remarkably low. And look at this. The yellow and black sticker here shows just how low the center of gravity is in the car. It's the same principle that allows the XSV17 stealth boat to flip the right way up when it capsizes due to its very low center of gravity. Tesla completed all of the various tests that form the rollover resistance rating, but the most interesting was the soil trip test. This is the test that went viral when Tesla tweeted it out. You can actually see the car thrown at a sand trap and forced into a roll. But Tesla did this with such high speed that the car rolled over completely, only for the car to immediately right itself. It's really important that cars minimize the rolling effect and protect passengers whilst doing so. But not all rollovers take place after sliding into a sand trap. Some can happen with violent steering inputs, like trying to avoid an obstacle. But Tesla has another trick up its sleeve in the form of adaptive air suspension. The ride height of the Model X can be adjusted from inside the cabin and can be raised for off-road driving or lowered for less drag, improved stability and less roll. It also features adaptive damping, which analyzes road conditions and responds to driving style, adjusting the stiffness of the dampers to suit. And this is incredible, especially when compared to the soft suspension that is normally fitted to large SUVs. This suspension helps them grip off-road, but it can make a roll much more likely on the road. And the Tesla can do both and adapt dynamically. And this is what makes it so great at these tests. When the car is being driven hard, the dampers tighten up to reduce roll and weight transfer, which allows the car to remain stable and help prevent it from rolling over during sharp driver inputs.